Okay, so this is going to continue on worksheet 4.4. We're looking now at question 2. I've set up the sort of basic setup from the question. So we've got a 5 Coulomb positive charge at -3 and a 5 positive Coulomb charge over here at 3. And then we've got charge Q4, which is going to be the test charge that we're dealing with in this case. So the equation doesn't really change. We're using F as a vector equals 1 on 4 pi epsilon naught Q1, Q2 on R squared. And by now, we can probably make a few simplifications. So for a start, let's drop K in just to save us some time and save a bit of writing. And then we're going to say, basically, let's say Q2 is our test charge. Remember, with the question here, part A anyway, is asking us to find the electric field strength. And electric field strength is force per unit charge. And given that our test charge here is a unit charge, that is, it's a charge of 1 Coulomb, we can basically we can change it so that it's F over Q, or in this case F over Q2, and that gives us an expression for electric field strength because it's force per unit charge. That leaves us over here with Q1 over R squared. And so then, in order to find out the electric field strength due to Q2 on Q4, all we've got to do is basically we go equals K, what do we got here? Q1, and so if that is this value, we go 5 coulombs over the distance, and again we're going to go the distance from here to here, which we're going to have to work out with Pythagoras' theorem. So we say this distance, this side of the triangle is 3, this side of the triangle is 3, therefore this distance here is going to be the square root of 9. So let's put that in, root 9, and obviously we square that, and we can probably work out that that's going to give us an answer of 9. So I wind up with my value for K, which was 9.0 times 10 to the 9 times 5/9. Plugging that into a calculator should give you a strength, and that will be the strength in newtons per coulomb, of course, based on the units from over here. So we got this in newtons and this in coulomb. So we get an electric field strength in newtons per coulomb, and obviously a positive point charge at this point is going to be pushed away from this charge here. So this the magnitude of this will be acting in that direction. So that gives us the vector quantity that we need. So that's that one. If we do then the same sort of thing for this charge, obviously the numbers will come out the same. So we'll still wind up with equals 9.0 times 10 to the 9 times 5 over 9. And I haven't got a calculator, so I haven't checked the math. But this vector here will be acting, because it's from this little guy here, big Q1, it's going to be acting up that way. And so at this point, it's going to be acting in that direction. So that gives us two vectors, one in this direction and one in this direction. And then we're going to have to add them. And that's because two electric fields, both acting in the same plate, do add as vectors. So we're going to have this one here, and we're going to have this one here, and we're adding them obviously there tit to tail. And we're going to have, we can sort of work out those values, but ultimately when you work at it, when you're looking at your resultant, which is going to go from here to here, we can say, well, I'm going to have to break this down into its horizontal and vertical component, and I'm going to have to break this down into its horizontal and vertical component. And we can be lazy about that and do it with Pythagoras' theorem, because we know that this is acting at a 45-degree angle here. So we can use Pythagoras' theorem to find out what the vertical component of each of these two vectors is, and again, conveniently, it will be the same. And then we can add them together, so this part plus this part, to give us the whole resultant vector. I'll leave you to have a crack at the maths behind it, and when I find a calculator, I'll go ahead and work it out myself, and I'll post my answer on Google Classroom, and we'll compare and see how we go. Anyway, good luck. If there's anything else I can do to help, let me know. Thanks a lot.